So today we are going to solve this problem. We have a system of two equations with two unknowns, x plus y is equal to 24 and x multiplied by y is equal to 48. I am going to show you two ways in which you can approach this problem and solve it. So the first way is going to be, we are going to take the first equation, x plus y is equal to 24, and we are going to express y in the terms of x. So we get 24 minus x. Now we can plug this result for y into our second equation, and thus we get x multiplied by 24 minus x, this was y, and that is equal to 48. Now, this equation can be transformed into 24x minus x squared is equal to 48, and then we get that x squared minus 24x minus plus 48 is equal to 0. And our job is to solve this quadratic equation, which we can easily solve using a quadratic formula. Just a little reminder here. A quadratic equation is given in the terms ax squared plus bx plus c is equal to 0, and its solution is given by a quadratic formula. x1 or 2 is equal to negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. As you can see now, we have in our example that a is equal to 1, b is equal to negative 24, and c is equal to 48. We are going to plug these results into the quadratic equation, and then we get that x1 or 2 is equal to negative minus 24 plus or minus the square root of negative 24 squared minus 4 multiplied by 1 multiplied by 48 divided by 2 multiplied by 1. And this is equal to 24 plus or minus the square root of 24 squared is 576 minus 4 multiplied by 48 is 192, and everything is divided by 2. So this is 24 plus or minus the square root of 384 divided by 2. The problem now is this number 384, which we have to find the square root of. So let's analyze this number 384. It is divided by 2 and we have 192. That is again divisible by 2, and as a result we get 96, which is again divisible by 2 and we get 48. By 2 again, 24, by 2 is 12, by 2 is 6, by 2 is 3, and 3 is divisible by 3, after which we get 1. We got 1, so that is the end of the algorithm. So 384 can be written as 2 to the power of 1, 2, 3, 4, 5, 6, 7 multiplied by 3. So we have 24 plus or minus the square root of 2 to the power 7 multiplied by 3 divided by 2. That is then equal to 24 plus or minus 2 to the power 7 multiplied by 3. This entire thing is going to be raised to the power of 1/2 because we have this square root, and taking a square root of a number is the same as putting that number to the power of 1/2. So this is then going to be divided by 2, and we get that this is 24 plus or minus 2 to the power of 7 over 2 multiplied by the square root of 3 divided by 2, which is 24 plus or minus 2 to the power of 7 is 6 plus 1 divided by 2. I am writing it deliberately like this because 6 is divisible by 2 and 1 is not. Square root of 3 divided by 2, which is 24 plus or minus 2 to the power of 6 divided by 2 is 3, and we have 2 to the power 1/2, which is a square root of 2, and then a square root of 3 divided by 2. So finally we have the result of 24 divided by 2, which is 12, plus or minus 2 to the power 3 divided by 2, that is going to be 2 squared, and this is a square root of 2 multiplied by 3, which is 6. And our final result is 12 plus or minus 4 square roots of 6. So x1 is now going to be equal to 12 minus 4 square roots of 6, and x2 is going to be 12 plus 4 square roots of 6. y1 is going to be, as you recall our equation, y was represented in the terms of x as 24 minus x. So we are going to use that connection, and that is 24 minus x1, which is going to give us 24 minus 12 minus 4 square roots of 6, which is equal to 24 minus 12, which is 12, minus negative 4, that is plus 4 square roots of 6. And this is our first solution for x1 and y1. We have our second solution here. x2 is 12 plus 4 square roots of 6, and y2, again using the same connection, is 24 minus x2, which is 24 minus 12 plus 4 square roots of 6, and that is equal to 12 minus 4 square roots of 6. So this is the second solution of our problem. And this method is the boring way to solve a problem like this one. A way more interesting approach to a problem like this one, x plus y is equal to 24 and x multiplied by y is 48, is the one that I am going to show you now. So we are going to take a look at our starting system of equations, and we are going to observe numbers x and y on the line of all real numbers. Now, between these numbers x and y, there is always a center C, which we can calculate as x plus y divided by 2, and there is a distance from the center to the dot y, which we are going to numerate as epsilon, and that distance is going to be y minus x divided by 2. Again, that epsilon also appears here as the distance from x to c, and that is the same epsilon y minus x over 2. So as we know from our system of equations, x plus y is equal to 24, and that means that c, which is given as x plus y divided by 2, is just 24 over 2, which is 12. So we know that center dot c is number 12. Now we can write x as x is equal to c minus epsilon. Looking this graphical representation here. From the dot x to the dot c, the distance is epsilon. The same approach we are going to use and write number y as c plus epsilon. Then we can use a second equation. X multiplied by y is 48. This equation right here. And by using that equation and these previous representations of numbers x and y, we get that c minus epsilon multiplied by c plus by c plus epsilon is equal to 48. This is now c squared minus epsilon squared, and that is equal to 48. Of course, we know the value for c, and that is 12. So this is 12 squared minus epsilon squared is equal to 48, and that is 144 minus epsilon squared, which is equal to 48. Epsilon squared is now 144 minus 48, which is equal to 96. And again, we are going to analyze number 96. It is divisible by 2, and we get 48, which is again divisible by 2. We get 24, by 2, 12, by 2, 6, by 2, 3, and by 3, 1. So epsilon squared is equal to 96, which is equal to 2 to the power of 1, 2, 3, 4, 5, multiplied by 3. Our job is to calculate epsilon. So epsilon is equal to the square root of 2 to the 5th power multiplied by 3, and that is the square root of 2 to the 4th power multiplied by 2 multiplied by 3, which is just a square root of 2 to the 4th power is 2 to the squared, and multiplied by the square root of 6. So 4 square roots of 6. And that is finally the value of epsilon. We are going to return these results here, and we are going to calculate x and y. So x is equal to c minus epsilon, that is 12 minus 4 square roots of 6, and y was c plus epsilon, that is 12 plus 4 square roots of 6. And thus we get one solution of our problem. Take a look at the starting system of equations. X plus y is equal to 24, and x multiplied by y is 48. This system of equation is symmetrical. You can write it as y plus x is equal to 24, and y multiplied by x is equal to 48, and by doing this you're not going to change anything. That means that the solutions also have symmetry to them, and that is going to give us a second pair of solutions. X is going to be now the value of a y previously, 12 plus 4 square roots of 6, and y is going to be 12 minus 4 square roots of 6. And this is the second solution of our problem. At this point, I feel an obligation to explain why I appreciate the second solution of this problem more than the first one. Let's try to solve a problem ax squared plus bx plus c is equal to 0 without using a quadratic equation. Our job is to prove the quadratic formula. So we know that a has to be different than 0, otherwise we don't have a quadratic equation. So let's just divide the entire equation by a, and that entire equation is then transformed into x squared plus b over ax plus c over a is equal to 0. We are going to introduce a substitution that capital B is equal to b over a, and that capital C is equal to c over a. The equation is then x squared plus bx plus c is equal to 0. And let's say that alpha and beta are the solutions of this equation. We are going to propose that the solutions alpha and beta exist. In order to prove that solutions alpha and beta exist, we have to find them. So if alpha and beta are the solutions, then this polynomial x squared plus bx plus c, which is a polynomial of the second degree has roots alpha and beta, and as the coefficient next to x squared is equal to 1, that polynomial can be written in the form of x minus alpha multiplied by x minus beta. So this is then going to be equal to x multiplied by x is x squared minus alpha x minus beta x and plus alpha multiplied by beta. So this is x squared minus alpha plus beta x and plus alpha beta. Then negative alpha plus beta corresponds to this b. So we have the first equation, minus alpha plus beta is b, and alpha multiplied by beta corresponds to c. We have a second equation, alpha multiplied by beta is c, and now we have to solve this system of equations. So alpha plus beta is equal to negative b, and alpha multiplied by beta is equal to c. Now, as you can see here, we have taken a problem of solving a quadratic equation, and we have turned that problem into a problem of solving a system of equations from the same type as the problem from the start of this video. Again, we are going to represent this system graphically. So we have a line of real numbers, and on that line we have numbers alpha and beta. Let's say that center dot between alpha and beta is the dot c, which is equal to alpha plus beta over 2. And let's say that eta is the distance from the center c to the dot beta. So this is equal to beta minus alpha over 2. That same distance eta appears here as the distance from the dot alpha to the center dot c. As you can see here, we have the first equation that alpha plus beta is negative b, and that means that c, which is a center dot, alpha plus beta over 2, is equal to negative b over 2. So that means that c is equal to negative b over 2, and thus we have found the center dot between points alpha and beta. We can write dot alpha as c minus eta, and we can write the dot beta as c plus eta. From the second equation, we have that c is equal to alpha multiplied by beta, and we have that this is equal to c minus eta multiplied by c plus eta, and that is equal to c squared minus eta squared. We have the value for c, and that is negative beta over 2 squared minus eta squared. So we have that c is equal b squared over 4 minus eta squared, and that is going to give us that eta squared is equal to b squared over 4 minus c. Therefore, eta is equal to the square root of b squared over 4 minus c. So we have that alpha is equal to c minus eta, and that beta is equal to c plus eta. So alpha beta is going to be c plus or minus eta, and that is going to be negative b over 2 plus or minus the square root of b squared over 4 minus c. So this is then going to be equal to, remember, b was in the substitution b over a, and capital C was c over a. So this is negative b over 2a plus or minus the square root of b squared over 4a squared minus c over a. So this is equal to negative b over 2a plus or minus the square root of b squared minus 4ac divided by a squared. 4a squared, and that is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So this is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. A little note here. We have here in the denominator of this fraction 2a. That 2a originates from a square root from 4a squared, from here. The square root of 4a squared is a square root of 2 multiplied by a squared, and that is the absolute value of 2a. This absolute value is going to be eaten up by this here plus or minus sign, and that is why I haven't insisted on it. So as you can see now, we have solved ax squared plus bx plus c to be equal to 0. It has solutions alpha and beta, two solutions represented by the formula negative b plus or minus the square root of b squared minus 4ac divided by 2a, which we have also denoted as x1 or 2. You can recall that this is the quadratic formula, and there you have the answer why I think that this is the better way to solving the problem. Thank you for watching, and I'll see you in the next video.